All right, continuing on. So we talked about our exponential functions and the derivative of that. And that was pretty easy, simple. Now we're going to go to our ln, natural log. And we're going to deal with that part here and work on some problems and everything with derivatives. So they outright give you the actual derivative of natural log x. So again, natural log x is derivative of natural log x is just 1 over x. So here, d dx, again, is natural log x is 1 over x. So example 4 first wants us to derive where we got this answer from. Because it's not just, okay, well, this is the answer. Let's figure out why it is that way so we can use what we know from the past to help us to figure out what's going on in the future. So just in case you happen to forget this, you still can be able to derive it and still be able to find your answer, and you should be able to get an answer. Right? So here, if we know that f of x is the same thing as saying y. So we're saying y equals natural log x. Now, one thing that we learned before back in pre-cal and hopefully maybe advanced functions or math 3, whichever class you learned it in, we found out about this thing with e. We know that natural log and e cancel each other out. So let's say this part here. We know that natural log and e cancel each other out, so the answer would just be x there. We know that here natural log and ln cancel each other. Natural log and e cancel each other out this way also. So here these cancel each other out, these cancel each other out, which gives you just x. So here, what we're going to do is kind of cancel out the natural log and deal with something that we have done before, or something that we've already found derivatives of, so that it makes it easier to work with. So if we look at this part here, there's this one rule that we have that we said that if the base numbers are equal to each other, then the exponents are going to be equal to each other. So here, what we're going to do is we're going to make this so that your y and your natural log are both exponents. Because again, we said if the base numbers are the same, your exponents are going to equal each other. So these are the same here, so they're equal to each other. So we kind of went backwards from the rule. So here, we know about the natural log, we know about e to the y because that's what we just did. But here, again, we talked about, I just wrote that over here, e and natural log cancel each other out. So on this side here, we get x. And on this side here, we get y. Now, we're going to take the derivative of both sides, the d dx of both sides. Take the derivative of both sides. And remember when we did implicit differentiation, when you take the derivative of y, you must have your dy dx, which works out as your derivative, or what it's equal to. So here, when we take our derivative of this part, we know e to the y is going to be e to the y, but don't forget your y prime or your dy dx. So here, this will be back e to the y, dy dx. And again, if you don't remember that, go back to 3.7, and that's implicit differentiation. And then derivative of x is just 1. So not bad, okay? So let's keep going. Here, we're going to go ahead and divide both sides by e to the y power. So here, we get dy dx equals 1 over e to the y power. Okay, now, again, if we go back to this step here, and I'm going to just go ahead and rewrite this all over again because I kind of like wrote through it. Remember, at this point, we said e and natural log cancel each other out. So we're left with e to the y equals x. So here, what we're going to do is we're going to substitute the e to the y and put x. We're going to substitute x in for the e to the y, I should say. That's what I'm trying to say. So here, we're going to do dy dx equals 1 over x, which goes back to the actual derivative of natural log x. So we derived it. So we took what we knew about natural logs and e's and the base e, and we simplified it down and found our derivatives by deriving it from what we know. Okay, so great. Wonderful. So that means it's not just something that we just made up or that mathematicians just came out of thin air. They actually derived it. Okay, so let's keep moving forward. So we have 5 and 6 we're going to do here before we go to our next video. All right, so now, just like we had on the exponential function, we said that e to the x was just e to the x. But then when it came to e to something for that exponent other than just x, we had to find the derivative of that, and it was e to the x times e to the u times du. So here we're going to kind of do the same thing. So instead of it just being x right here for the natural log, we're going to have a function there. And when we have a function there, we're going to find the derivative of natural log, which is 1 over u. But then we still have to find the derivative of u. So when we do our derivative of natural log u, or natural log of something other than x, we're going to do 1 over u times derivative of u, du dx. Or another way that they wrote it out was if you multiply 1 over u times u prime, that would be u prime over u. So either way you see it, either way you look at it, it's going to be the same thing. So either one of these is going to be the right answer. If you work it out, it'll be the same thing. All right, so let's take a look at these parts down here, and we're going to find the derivative, first derivative of these. So here, example 5 says let y equals natural log 2x plus 2. Find y prime. So again here, we're going to say u is equal to 2x plus 2. So if we were to find the derivative of y, that would be 1 over u times u prime. And again, this would be consider our u. So we write this as y equals natural log u. Okay, so we got that. So 1 over u, we know what to do with there. But u prime, again, we have to find. So here, we're going to find the derivative of this part. So u prime would just be 2. And then here, we substitute the values in. So here, that's 1 over u, which is 2x plus 2, times u prime, which is 2. And here, again, for the final exam, or for AP test, sorry, you can leave it here. If they just ask for the derivative, that's fine. If they want you to use that derivative in this and a normal line or tangent line or something else when it comes to what we're going to talk about in chapter 4, simplify it down. That's okay. But if you simplify it down incorrectly, that means your whole work is going to be wrong. So, yeah. So here, this part here, if you factor it down, you should be able to get 1 over x plus 1. Great. All right. Now, when it comes to example 6, same thing, same process. Again, this would be f of x equals natural log u, where we know u would equal tan x, or tangent x. So again, just like we did here, we're going to find the derivative of this function. So this is going to be 1 over u times u prime. Derivative of u, a derivative of tangent here, is secant squared x. Derivative of tangent x is secant squared x. So we're going to do 1 over tan x times secant squared x. And again, you can leave it there, or you can put it into one fraction. Sorry, f prime of x. And again, for the AP test, you can leave it here. If it just wants you to find a derivative, leave it here. Or if they want you to simplify it down and do other things, you can come here. All right, so that is the end. That's the examples 4, 5, and 6. And so we have one more video left to be able to do the rest of these examples, and then we're done.